This activity will help you practice with the control signals for this forward A and forward B. So you will be able to identify what forward A signal should be generated for any particular case. So suppose we have this program, again the same thing, x2, x1, x3, the same program exactly, which is not maybe, yeah, it's the same thing. But this time we are trying to analyze the situation in the single cycle clock diagram. What we are supposed to be doing is to write the signal values of this instruction, these signals. Okay, so let me try explaining to you how should you be writing the values. So for example, when the instruction is in this phase, so when the instruction is in the instruction decode phase, so in this diagram we have excluded the instruction fetch phase because there is no point of including instruction fetch phase. So here when the instruction is in instruction decode phase, you see the IDX RS1 is not updated yet in this register. So just to clarify that this RS2 is not the one which is going into this mux. It just shows that the value of RS2 sitting in this IDX register. Similarly, RS1 value sitting in this register. It may also be containing some other data like the actual data of RS1, actual data of RS2, another instruction, another control signals. But what we are referring here is the value of RS2 and the value of, so not the value of RS2, the actual RS2, the register number, and the register number RS1 here. Okay, so when the instruction is in this phase, there is no this value is not updated in this register yet, so we do not have, so you can specify with the dash only. Okay, now once this instruction moves to the next stage, next phase, then the next instruction would be in this instruction decode phase. Now at this point in time, here you can see you have to write the value stored in the IDX register and the XMEM register. So IDX register value, whatever the value of the IDX register is. So just to let you know that the IDX RS1 would be X1, IDX RS2 would be X3, and XMEM RD is not updated in this case yet. It must not have been updated in this case yet. Okay, so give a pause and fill out the activity sheet, which contains 4 of these diagrams capturing all the 3 execution of all the 3 instructions. So give a pause and then you'll proceed ahead with the solution. Okay, so when the instruction is in this phase, you see what will be the value of forward A and forward B? We do not know at this point. So IDX RS1 is X1, IDX RS2 is X3, but this value of RD is not updated in this value in this register yet because it is currently being executed here. Once the clock cycle is finished, only then this data will be updated here. So currently we do not have the information about the RD, which means that still the forwarding unit will not be forwarding data from this register or this register. It will still be fetching the data from the register file. Okay, so which means that the forward A and forward B value would be 0, fetching the data from the register file which is stored in the IDX registers. Okay, now when the instruction proceeded ahead, moved forward to the next phase. Now in this phase, what will be the value of the XMEM reg write signal? The XMEM reg write signal is of course 1 in this particular stage. It was already 1 because of this condition, because of this instruction, because it is writing the register back, the results back into X2. That's why the reg write signal is 1. Okay. What about this one here? What will be the value of XMEM RD here in this case? So XMEM RD currently contains the value X2. Okay, and let's see what will be the value of the mem write back RD, because this register has not been updated yet because this clock cycle is not finished. We are assuming that. What about this IDX registers? So IDX RS1 and RS2 will be containing the X2 and X5. So at this point in time, you can see XMEM RD is equal to X2, and which is equivalent to IDX.RS1 X2. So the condition or the policy for forwarding the data is satisfying here. The RD is not equal to X0. Okay, reg signal is also 1, and this is matching with this value. So in that case, the value of RS1, the source RS1 for ALU must be coming from 2, if you follow this path, it must be coming from this register xmem, which contains the updated value of this operation x1 minus x3, whatever the value is. It's supposed to be written in x2, but it is not written yet. It is stored in this register. So this instruction should be using the data from this register and not fetching the data from this register file, which does not contain the updated value of x2. Get it? So if we move ahead now, at this point in time, the mem write back register write signal is 1, this one is also 1. Here is RD is x2, the RD is x12 here in this case. And what about the RS1 and RS2 here? So RS1 is x6, RS2 is x2. So for this one, RD is not equivalent to any of the source register, but here the RD is equivalent to one of the source register RS2. So the data for RS2, the second input of ALU, must be coming from forward B, which is the forward B signal is 1. It must be coming from this mem write back pipeline register, because the updated value of x2, which is the x1 minus x3 operation, is placed in this mem write back register. Okay, so and by the time this instruction reached the next phase, it would always, of course, be written, the correct value of x2 would be written into the register file. So any instruction coming after this instruction do not need the forwarding.